want to spend some time this morning just on some really pretty easy stuff, and I want to talk about angles and standard position. I just want to remind you that an angle is where you take two rays, right? You're going to draw two rays, and what's going to make them an angle is that they're going to share the same vertex. So what we do is we call this side here the initial side. Then we open it up, and where it ends is called the terminal side. So this is actually pretty easy. So here's our angle, and our angle is this right here. So this is our angle theta, which is what we just usually call angles. It's the name that we give them. What we're going to do a lot in trig is that we're going to take our angles and we're going to put them in something called standard position. So what we're going to take is the Cartesian plane, like this, and then we're going to take our initial ray, and we're going to say that our initial ray lies on top of the x-axis. This is really important. It lays on top of the x-axis, and its vertex is at the origin. So really important, right? And then what we're going to do is we're going to open our angle up this way, and here's our angle. So here's our initial side. We're going to open it, and this is going to be our terminal side. All right? This is not real tough stuff, but you have to know it, and this is kind of where people screw up sometimes. They say we have this thing in this form. So also I want to be clear about one thing, that these angles here, this is the initial side, it opens up. So when it's in standard position, the terminal side will lay either on the x-axis. If the terminal side lies anywhere inside quadrant, this is quadrant 1, this is quadrant 2 if you remember, this is quadrant 3, and this is quadrant 4 down here. If it lays inside of these, then we say that our angle falls inside of quadrant 1, 2, or 3. If our angle happens to fall on the y-axis, on the x-axis, or on the y-axis down here, we say that our angle is a quadrantal angle. All right? So this is an example of an angle that terminates in quadrant 1. Let's take the same ray here. This one is in quadrant 2. If I take another angle and put it in quadrant 3, so quadrant 3, the angle, or quadrant 4. So here, put our our initial ray in first, then put this ray in, and this angle is a quadrant 4 angle. All right? So I think that's what's going to be really important. The next thing I want to make sure that you get is that if we take an angle here, let's say we take this angle here, this is really important. Take our angle here. If we open our angle counterclockwise, we say it's a positive angle. So let's take this angle right here. And if we open it this way, right, without regard to where it ends up, we open it this way, we have positive angles. But if we open it the other way, if we open it clockwise, so it looks like this, and we open it this way, without regard to where it ends up, so we go this way, and then this way, and then this way, we end up here, this is considered a negative angle. So, negative angles. All right? So, what things should we have talked about so far? We should have talked about initial rays, terminal rays. We should have talked about standard position, and hopefully you got what I was talking about with negative and positive angles. Look, I hope this video is helpful. If you haven't already subscribed, please subscribe, and your comments are always welcome. Thanks.